Good early afternoon. How you doing? Well, it's a little cool out here. If it wasn't windy, it would be nice. This is my old Ryobi drill. Now, one of my viewers suggested that I use a drill, and I have thought of that way back when I first built him. This Ryobi, the batteries have to be constantly on charge. It's a 12 volt, but it has to be, it's a good drill, but the batteries, I have two of them, they have to be on charge all the time. So that's why I got the Harbor Freight ones. By the way, those are cheapies, but they work very well. And of course, naturally, I got the DeWalt for the heavy jobs. But anyways, what I did here is I cut the head stick back quite short here, quite short. And it temporarily moved took off the mouth trigger and moved it off to the side. I can't cut it up any shorter than this because the mouth trigger has to mount here. So what I did is I just stuck this on. This is a wooden dowel that I used when I originally built them so that he turns easily, but it's all rigid now, and I put these 4 nuts on here because I may want to put some rubber tubing over and I can clamp it to it. So what I got to do is to mount this up in here, and it's not centered yet, and then I got to drill through and put a screw in here so this whole thing will turn. But it's lopsided, and because it's lopsided, there's going to be a problem with this business. What I did is took the drill, I did this off camera, and stuck it up in here, tightened the chuck up and held it in place, and it turns the head quite nice, but you can't run it at full speed. You have to run it like that. Now, I've been looking online to see how these things work. And I really didn't get too much information. I understand there's a, I don't know if this is pulse width modulation or not, type of thing. I don't know too much about that. I guess there's a triac in there or something. But what I need to do is to be able to, I'm gonna have to butcher this up, take it apart. The batteries are no good anyways. I want to use the 12 volt battery for Dorkel to run. But before I do anything, what I want to do, and I'll do that on video here if I can, is I want to measure the current, because some of the forums I've been checking, questions on, guys I guess want to use some of these drills for robotics and stuff like that, and they want a variable speed. And this is perfect, but you don't want this running full blast. This is 550 RPM. As I recall, I think that's what it said on the label here. So it's got to run probably like that. And I tried it, and it's quite good. It turns the head substantially from one extreme to the other. But what I want to do is I got 2 clip leads, and I'm going to try to clip them into the battery here. It's not going to be easy getting in there. And see how much current this thing draws. Because on some of the forums, what I've been reading is the slower your drill runs, the more current it uses. And less torque. Now, I don't know. If I can somehow get this trigger switch fixed in a fixed position, because I'm going to take all this apart, so it's not going to have a case to lock this in place. And I really would like to have it controlled, so I don't think I can put it onto the remote. I would have to open this up and see how heavy the wires are that go to this. To be honest with you, I'm not quite sure how these things work. But it's not a simple variable resistor or a rheostat. It's not that simple. And from what I understand, you're losing power when you reduce voltage. Obviously your motor's running slower, but it makes sense that you're going to lose power too. So I want to see how much current this draws. My amp meter, I think, will only read up to 10 amps. So I'm going to see if I can find it, check the current. Matter of fact, I don't think I'll even use this battery. It'd be easier to clip onto the Dorkel battery, because this is 12 volts and the Dorkel battery is 12. So we'll use the Dorkel gel cell on this, and we'll see what the current draw is. If I can put some kind of a load on it, simulating the head stick at slow speed. And if it's under 10 amps, which I don't think it is, we may have something here. If not, I've gotten some good advice from a lot of my viewers. One of my viewers wants to send me a card window motor, which might do it, but I don't know how fast those things run. If it runs as fast as this gear motor I got over here, which is 150 RPM, it's going to be too fast. So these are things I have to actually try out. Well, I killed my drill, and I'll tell you how I did it. I put the clips on here correctly, and I had the drill running, variable speed and everything else. This battery's fully charged. And so I left it in the forward position, and figured, well, I'll reverse the polarity because it's the brush motor and it should go backwards. Well, it didn't. It went slow and it stopped. And the cord and the wires were warm. So I put it back on the right polarity again, and did. Like I say, I don't know that much about these things. I burnt out the switch speed controller, which means that I can't use a drill anyways. So I am out of luck. So using an electric drill, I'm afraid that's going to be out. So can't test any current today. And we're back to square one with the motor situation again. Now I could eliminate this, and most likely the motor's okay, because I think what happened is it burned this out. So it must be some solid state, whatever it is in here. I don't know how they make the variable speed. And nobody seems to explain what's inside these things. And I've spent some time on a computer today. So I don't really know how they work. I always thought it was a variable resistor. But how it could handle the current, I don't know. So the only option I could do, since I ruined this drill anyways, is I'm going to take it apart. I gave all my damn rheostats away too. And put a heavy-duty rheostat in series with the motor, but by the time I get through ordering all that stuff, I'm better off just getting a motor from American Science and Surplus. They have a couple of motors over there that may work, or see if that car window motor might work. This is getting to be a little bit of a pain in the backside here, I'm telling you. Alright, I'll come back on the video in a minute. I'm going to take this thing apart and see what's inside of it. Alright. Well, I really don't know what the heck is in these things. But now I don't know what that... Oh, I see. It switches inside this. So, according to that, I would think it's a switch that goes side to side here. Hear it? That would seem to be a polarity reversing switch. Well, I removed this damn thing because obviously it's burnt out anyways. I have no idea how these things work. This seems to be a polarity reversing switch. But I guess when I reverse the polarity at the motor terminals here, at the battery terminals, the battery terminals, when I reverse the polarity here, it must have blown this out. But I don't understand. It must be some solid state stuff. This looks like some kind of an SCR or something here. But whatever. I'm not going to be able to utilize that anyways. So the only thing you really got to work with is this. So this alone, with the chuck and everything, would work, but I'm running full tilt with this. So I'm right back to square one, trying to get a motor that's going to run slower. Oh well, I didn't mind sacrificing this drill because the batteries are no good anyways. I've had this drill for quite a few years, and it's been a very good drill. One of my, for a cheap drill, it did pretty good. Alright, motor experimenting time. Alright, we're going to try reverse polarity on this, directly on the motor. The only two damn clip leads I've got here. So the yellow is a positive in this case. It's a brush motor, so it should work either way. Alright, we're on the positive with the yellow because I don't have a red wire. And the black is the negative. Now this will probably, I'm going to have to hold this. This is going to really fly here. Just hold this down. Obviously I can't be going that fast. Alright, now we're going to reverse it. Alright, no problem. No problem. So I didn't think there would be with a DC motor with brushes can be reversed. I didn't think there was a problem. What I messed up on is not knowing how these things are and how they're made and how they work. I thought it was a heavy-duty rheostat. So my worst fears came true. So obviously I probably blew this out. I think this has got 3 leads on it, so it's probably some kind of a SCR. I don't know too much about that. I was never much into solid state and SCRs and triacs and everything like that. I was never not much good at that. I like the vacuum tube stuff. So I'm not too educated on this. I'll be the first to tell you that. But anyways, now I got to find a way of reducing the speed of this without losing the torque. And if it gets involved with circuitry, which I can't do because of my eyesight and not having a shop or place to work, and it's cold out here today, the wind is not too kind to me today. So I can't build anything. So I think we're back to square one, but I'll hang on to this because this is a good thing for some kind of a project. So what I'm going to do here is this is definitely going to stay here, the way I got this shortened up here, so I can get some kind of drive on here. And ideally, I'd like to have a little piece of hard rubber, not hard, but strong rubber hose to come down. So when this can flex, it's off center, it can flex and it can move the head as it's turning. And that's why I shortened it up, and also to accept the electric drill. But the electric drill idea is going to have to be scrapped because the speed controls are not cooperative with the way I want to do things. Other than using the rheostat and I don't think we can. So I didn't measure the current of this. I'm not even going to do that. I know I said I was originally, and that's only because of the speed control was working on that until I reversed the motor connection while this thing was still in the unit, in the drill. So I'm not going to, there's no point in measuring the current of this motor because I can't use it running that fast. I need to know what the current is when it's running at a much, much slower speed. But we're going to have to find another way. So once again, ladies and gentlemen and boys and girls, I want to thank you for watching. I guess Uncle Dorkle's going to have to go back into the shed until I come up with a system. I'm working on it. As long as we get a halfway decent day, I'll stay with it. When it gets cold, well, I'll have to do it next year when it warms up again. Thanks for watching. If there's any more updates, you'll be the first to know.
This ain't no dog and pony show! What do you think this is, anyways?
Why don't he stay dead?